Alright, so hi guys. I was trying to record a video a few seconds ago, but anyways. So I hope everyone's doing well. I'm so sorry for the lack of uploads. I've just been insanely busy and also just dealing with personal problems, but I am doing okay. Now, in this video, what we're gonna do is we're gonna go over how to find we're going to go over this problem. So we have given sine of theta equals -3/8, where 3 pi over 2 is less than theta is less than 2 pi. Find sine theta, sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Now, this one, of course, there's two ways to do this. And I don't want to drag it on, but I'm going to just write down the different formulas. First of all, we want to know what this part means, and what that means is that is in quadrant 4, so let me just kind of draw here. Okay guys, here we have a quadrant, right, and I'm gonna just try to draw a kind of a rough sketch of a triangle, a right triangle. Now, you want to remember that from I'm pretty sure we learned this from the unit circle. If you like working with degrees better, you should try to change this to degrees if you want. So we want to know that this is 270 less than theta less than 360 degrees. Now, here, that means that, so we have 0, pi over 2, or 90, and then pi, and then 3 pi over 2, and then 2 pi radians. So what I'm gonna do, I'll do my best to draw it. Now, like I said, it's gonna look something like this, and remember that my y term, so remember that sine of theta is equal to my y term, which is y, over r, which is my radius. So, and if y'all want to see that more visually, we know that if this is theta, this would be the x-axis, this is the y-axis, and then this would be my radius. The radius on a circle is the same as hypotenuse. Radius is the same as hypotenuse. So that's why we say r, right? Now, like I said, it's y over r, so sine theta is -3/8, so really we know that my y term will be -3, so we know that in this case, this is -3, and then my r will be the radius, or the hypotenuse. So again, this is y equals -3, and then my radius is whatever this part is, and that was equal to what? 8? So you want to kind of be able to understand that. Now, we know that, again, this is considered a right triangle, so we have to put a right angle there. And then, let me think here, -3/8, and then, so it's going to be over, and then we're going to do 8. Now, here, we're going to go ahead and find, you can either use Pythagorean identity, or you can use, the SOHCAHTOA stuff. So, just to kind of show y'all, I'm going to try to do this pretty quickly. Sine squared theta plus cosine squared theta equals 1. I don't know why I still have that on. So let me just try to do this as quickly as I can. So this is the Pythagorean identity. And And so we know again that sine theta is negative 3/8, so really what this means is this is sine of theta quantity squared plus cosine of theta quantity squared is equal to 1. Of course, guys, you can also use the Pythagorean theorem and just do the cosine. Actually, let's do that instead. I don't want to do it this way. You can do it this way, but yeah, I'm not going to do it that way. So what I'm going to do instead of Pythagorean identity, I'm going to go ahead and do, what is it called? SOHCAHTOA. So I know that cosine theta is the adjacent side, so it's really x over r, right? So cosine theta is x over r. And we know this from the unit circle, guys. If you don't really know the unit circle, I recommend, I do think I have videos on that, but I do recommend you know it before you get into these kind of problems. Now, so sine of theta, so again, we want to say the Pythagorean theorem is going to be, we're going to do x squared plus y squared. In other words, this is just, it's the same as Pythagorean theorem. We're just going to do it this way. Equals r squared. So then this is going to be x squared plus negative, so it's going to go x squared plus negative, the quantity negative 3 quantity squared is equal to 8 squared. Okay, now we're gonna just go ahead and simplify this and solve for x. Now you do wanna understand that in quadrant 4, cosine theta is greater than 0, x is greater than 0. Okay, guys, I really want to emphasize that because once we take the square root, we're gonna go ahead and make it positive. So let's do that. So we're going to do x squared plus 9 equals 64. Okay, and then when we subtract 9 on both sides, let's do that really quickly. We're going to end up with the following. X squared is equal to, I think it's 55, and then from here, I'm just gonna make sure. I think it goes like this. Yeah, and then we're just gonna take the square root of this. Okay, and again, remember to do positive. So x equals square root of 55. That's really what all that is, right, guys? And so, let's see here. Sorry, guys, hold on. Did I mess up somehow? Give me a second, guys, I'm sorry. If I do, hold on, give me 1 second, guys. Okay, I think I messed up on the actual, okay. So here, we're gonna go ahead and say the following. So we know that x is positive square root of 55, so that we're gonna put that in here. So for right now, we're literally just solving for x and all that good stuff. Give me a second, guys, I'll be right back, hold on. Alright, guys, hopefully y'all can still hear me. Let me make sure. So, sorry about that. So, what we're gonna do here, and I went ahead and did this part. So we know that x is square root of 55. I did it wrong originally on my paper, but it's actually, I accidentally had said square root of 55 and not, or square root of 53 and not square root of 55. Anyways, so here, we're gonna go ahead and, like I said, we put that right here. And so we know that cosine theta again was x over r, and we already have sine theta. So really, what we're gonna do is, we know that cosine theta, so this is gonna be the square root of 55 over, actually, let me make that better. And then over, and then my radius, which was 8, right? So this is what we're gonna get. And so, here, we're just gonna, so we know that cosine theta is positive, so I know that cosine theta is therefore square root of 55 over 8. And then again, we have that sine theta. We were given that. We said sine theta was negative 3/8. Oops. So again, and we have, so sine of, so thus sine of 2 theta we know is 2 sine theta cosine theta. And then we're gonna go ahead and do, so we know that again we have these two things, and then we're gonna say the following. We're gonna have, so we have this here, which would be this, and then we will have the sine theta, which is this part. So then we're gonna do 2 times negative 3/8 times square root of 55 over 8. Now, if you think about it, this is going to be negative 6 over 8, and then times square root of 55 over 8. Now, here's the thing, negative 6 over 8 will how do you say it? It's gonna, it is going to, reduce, I'm sorry. And then, we're gonna have negative 3/4. So, and then times square root of 55 over 8. And then from here, we know that, I guess from here, we're just gonna go ahead and say that this is equal to negative 3 square root of 55 over 32. And this would be sine of 2 theta. So thus, sine of 2 theta is equal to negative 3 square root of 55 over 32, I think. If I made a mistake, guys, let me know if at any point. But if at any point I make a mistake, please do comment down below. Sorry if it's taking me a while, guys. I'm really trying. I just don't want to go way too fast. Here, so then cosine of 2 theta, we know that from the double angle identities, it's this. For, you know, for time purposes, I'm not really gonna define the other two identities. Actually, I'm just gonna write them down. Give me a second. Okay, guys, these are the basic 3 of them that we can do. It doesn't matter which one you choose. Sometimes it's better to do one, sometimes it's better to do the other. But, yeah, so here, we can just go ahead and use either one of these. So we can say, let's just use the second one, or let's use this one. So again, we know that, or no, I'm sorry. Let's use the first one. So, this one. And again, we know that sine theta was equal to -3/8. So then we know that here we're just gonna have 1 minus 2, and we're gonna put sine theta squared. So really, sine theta is this, and we know when we square that, it would just be 2 sine squared theta. And so we know that, again, this is cosine of 2 theta, and so when we plug this in to this, we're gonna get 1 minus 2 times -3/8 quantity squared, and this will be 1 minus 2 times 9/64. 1 minus 2 times 9/64. And if y'all think about this, let's just put this, and actually I don't know if they let you use a calculator. If they do, that's fine, but if they don't, what you're gonna do is, we know that this is 1 minus 2 times, it's gonna go 9/2 times, and it's 32, I think. And so then, from here, we know that this cancels out, and so this will be 1 minus 9/32, which equals 32 minus 9/32. Let's just do the calculator. I'm sorry, guys. And this actually becomes 23/32. And here we know that the cosine in quadrant 4 is positive. So I just want to state that very quickly. That's going to end up being positive. So just to kind of, 1 second, guys, let me just double check my work. Okay, so we are on the right track, guys. And that is how you do the cosine of theta, of 2 theta, excuse me. Again, it doesn't matter which one of these you choose. You can choose any one of these. It doesn't matter, but I think it just depends on the problem. I think one is more convenient than the other. It depends. Now, let's move on finally to tangent of 2 theta. Now, with the thing with tangent of 2 theta, we know that this is 2 tan theta over 1 minus tan of theta squared. However, we can say that tangent of 2 theta, we know that because tangent of u is equal to sine of u over cosine of u, let u equal to theta. Thus, sine or tangent of 2 theta can be equal to sine of 2 theta over cosine of 2 theta. So we can do it this way. I don't want to do it the other way because, I don't know, I think this way is better because we already have the sine of 2 theta and cosine of 2 theta. All we have to do is just plug it in, or plug those in. So use your previous 2 problems to find tangent of 2 theta. Now, here, so like I said, we have sine of 2 theta equals -3 square root of 55 over 32. So negative sine of 2 theta and given from previous problem, sine of 2 theta equals negative 3 square root of 55 over 32, and cosine of 2 theta equals, and it was what again? It was 23 over 32, I think. Yeah, so it was 23 over 32. Now we're just gonna go ahead and just clean this up. So tangent, thus tangent of 2 theta is equal to, it's gonna be this, negative 3 square root of 55 over 32 over the cosine of 2 theta, which was the 23 over 32. And so here, again, now let's do again that stuff of you know, dividing fractions. If y'all know how to do this on your own, you don't have to watch this at this point, but you can just skip forward to see if y'all got the correct answer. But here we just have negative 3 square root of 55 over 32. So keep it, change it, flip it basically. And then times, and it's going to go 32 over 23. This cancels out. This gives me negative 3 square root of 55 over 23, I think. And this is what tangent of 2 theta would be. Thus, we have our final answers are sine of 2 theta equals, I'm sorry, negative 3 square root of 55 over 32. Cosine of 2 theta was, sorry guys, give me a second, 23 over 32. And then tangent of 2 theta was I'm almost done, dear God, was negative 3 square root of 55 over 23, so these three are our final answers, guys. And that is going to be it for this video. I know this was really long. I'm going to try to, you know, try to cut it short, like cut some parts out, because I know this is really long. So I'm going to try to not make it super long, but yeah, these are really lengthy. But if anybody does have any questions, please let me know. And I really hope that did help, guys. And again, I'm sorry for the lack of uploads. I've just been so busy. But with that being said, thank y'all so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye guys.